Hello. Hello. Can you hear me?
Yes,
Yeah.
sir.
I'll start the session now because some of the participants will be joining slowly. Some are there on YouTube also, so they'll be joining. I'll start participants with the very brief formal introduction of Dr. Phanindra. Uh, he is a manager for Star CCM Plus and HEEDS MDO software. He has done his PhD from Turkey and was earlier lecturer of fluid mechanics in Ethiopia. He has an extensive experience in CFD softwares and is doing extensive work in that area. So instead of giving a very long introduction, I think he will speak for himself the way, because I have earlier attended his lectures. So yes, definitely we will be gaining a lot during his lectures, and I will straight away ask Dr. Phanindra to take over and start his session. Yeah, Dr. Phanindra.
Hi all. I hope you can hear me.
Yeah, you are audible.
Thank you. So good afternoon all. Thank you, Mr. Aqleem, for that wonderful introduction. So guys, so I'll be preferring to have a bit kind of interactive session. So first of all, let me say, like, we are from industry background, not from academic. So naturally, we may sound a bit different than usual. I don't go into very much theory, but try to focus more on the practical aspects of EV. So feel free to communicate with me and just try to ask questions if at all you are stuck, and then I'll be very happy sharing whatever observations I have, and at the same time even to learn from you guys. With that, I will like to open the session about battery selection, sizing and simulation, which was the topic of today. So in overview, like we would like to first of all discuss about the challenges, and then the solutions, possible solutions, and why should one go for simulation solutions, why not for other solutions. I mean, that is a matter of fact. And also we'll try to have a glance about various manufacturing challenges also. I guess these kind of inputs will be of great use for academics, because you will be directly dealing with the next generation engineers. So a kitty or among us, a discussion on these topics may help to open up new R&Ds of great interest and significance. As I said, like we'll try to share about these aspects from industry point of view. So now, if at all we see the worldwide, what is the current biggest challenge? Reduce carbon dioxide emissions. Now the first question is the carbon dioxide is the only enemy for the world? Not exactly, actually. If we see the nitrous and sulfur oxides and other oxides associated, or any chemicals that we try to use in the refrigeration systems, even they are equally harmful, or in fact they are more harmful to environment. But now, why the world is running behind carbon dioxide? It is because the amount of carbon dioxide produced is in gigatons, whereas the rest put together is not even more than 10% of what CO2 volumes are coming out. That means CO2 emissions are the biggest challenge. And naturally, whenever we talk about carbon dioxide, there is always a topic which comes to the alternate energy sources, because then I feel that is the best vehicle we can have. Unfortunately, right now we don't have any vehicle as such proven. We have recent releases from Tata Motors and other, if I'm correct, Kia also came out, but Tata Motor Nexus is the best challenging vehicle that is available right now in India. Mahindra Reva was trying to come, but that is like a nano model, but the biggest model is still awaited from Mahindra. So Tata came out with this vehicle, but that vehicle is found with a lot of thermal issues. Now, where the thermal issues will come from is because of the changing atmosphere. I mean, a vehicle that is is found suitable for Pune may not be suitable for Hyderabad. So it should be tested at different atmospheric conditions. The vehicle should be subjected to various conditions before it is launched. But first come first basis works always in market. So of course, even the big companies, they try to rush. So there is a heavy R&D going parallelly, at the same time output is also expected. So this is bringing a lot of pressure on the automotive sector also at the same time. But yes, this is the cutting edge technologies is expected in these areas that can really address batteries which will last long. And now when it comes to battery manufacturing, I would like to say, like currently in India, we don't have indigenous battery manufacturers. It may sound a bit strange, but it is a fact. We don't have them. We have people who assemble, or we have many companies which are importing. But is it like industries are not trying? Not exactly. Many industries are trying to come out with their own batteries, like Electra, who launched electric vehicle buses for in Gujarat for almost 6 or 7 years back. It is one of the leading bus manufacturers based on EV inputs, EV batteries. So Electra is now trying to come out with their own battery, patented. And Exicom, that is a two-wheeler manufacturer, they are also coming out with their own batteries. And there are a couple of companies which are started by IIT students again, IITs, and I get the Coimbatore Institute of Technology. There is one college that guy started in Coimbatore. They were trying to formulate based on alkali-based battery vehicles, as well as in Kolkata. I feel Exide Industries, Kolkata and Chennai. I feel two plants. They are now working severely for getting indigenous batteries, but honestly, as of now, we don't have it because we have confined with the lithium-ion chemistry, and of course, lithium reserves. If you see overall in India, is very less, or you can say negligible when compared with China. And of course, that's where the China is trying to act like a real dragon nowadays. Their behavior is worse, but they are acting like real dragon because they possess these mineral resources with them. But nothing less, there are many alternatives are possible, and we are working. There are many alternatives are possible, and the work is going on, because it's not only China. It has been always told like Chinese have this, but not only China. Nowadays, there are many other countries. Basically, African countries are found to have highest resources, reserves of these minerals. So new collaborations, new equations are found happening globally. Like petroleum, when petroleum was found, petrol boom, we say, like around after the Second World War, petrol boom was found in Saudis. I mean, after the First World War, it was started. By Second World War, it came to a stage like the boom started, and we all know like Saudi is and Gulf countries, how they developed in 60 years. I mean, in proportion with the petrol prices, by giving away the raw material, they earn a lot of money. Similarly, now the African countries, and of course the green reserves in India, especially in the south side, a lot of forest which are there, which have been declared forest, but they found the traces is possible of extraction. Once we have those reserves, definitely electric vehicle possibility is there. Why I am giving all these inputs is I just wanted to give you a flavor of happenings across India before we go and confine ourselves with the battery and its advancements. Anyone would like to have anything till now, or shall we continue with the next slide? Kamlesh, am I audible?
Yes, you are perfectly audible. Yes.
Oh, okay. Because I thought I am going one way. I thought even signal is lost.
And the format is that we have kept all the attendees mute at present. So during question answer session, I will give the permission to unmute.
Oh, okay.
Yeah. Oh, yeah, I'll be definitely responding to your questions.
Okay. Thank you, Mr. Aqleem. So yeah, now we will try, as I briefly like, digital twins are the replicas. Now with that, we'll try to see, now coming to the heart of the subject, that is the battery. I mean, all this success will rely on battery. Now, what exactly the battery manufacturers should be focusing on? If at all you want to develop your own indigenous battery, what is that first thing that one has to develop, or first thing one has to address is to come out with a realistic model of the existing battery. That means you procured a battery. I'll tell you, there is a battery manufacturer recently for whom I was sharing the same. Like they are trying to import from China, and because of certain restrictions, it stopped. So altogether, the company is now in losses, or they are still hold in terms of R&D. They are trying to get it from USA at higher prices and all. So why they now once assume like you have brought your battery, what is that first thing that you need to do? You need to convert that battery into a mathematical model. Believe me, that is going to be a starting point for many R&Ds as far as automotives are concerned. Because if you have a model that is replicating the battery, it will be easy for you to design entire automotive that can utilize this battery effectively, and any battery with a similar capacity effectively. Now, once you fix the rest of things and then you say this is my energy density requirement, that energy density requirement can be found from many suppliers in the market competition or the original cell manufacturer. You can say this is my power density. So this realistic model covering is required. Second, there is no doubt workflows should be taking place and workflow should be developed and maintained. Workflow by means end-to-end process. That means, as I said, like if power density is given, we must know which vehicle it is suitable. That in-between process should be optimized. And definitely the biggest challenge is optimization. Optimization, previously we used to say the word optimization frequently when we used to deal with a single variable. And then when we have more than two variables, we used to refer it as a multivariable optimization. But later on, when these parameters, variables were relevant with the designing of the component, then we started referring it as multi-design optimization. But if you today see in industry, we refer it as design space exploration instead of calling it as optimization. Why? Because when you have a single variable, you will have a one maxima or one minimum, more or less. Now, when you have two variables, there can be a probability of factorial 2, out of which you need to find out the best. Now, you say you have 100 variables. As I was referring, just take randomly the variables that we know already. Length, breadth, width, that is 3 dimensions. So we have the 3, which refers to the volume, and then material, and then cost of the material, supply time, and then cost of the supply time, manpower involved, and then cost of the manpower involved. So manpower involved can be measured in hours, and then again cost will be mattering. So now you keep adding all the parameters that are involved in your manufacturing. Then you will see the original battery that is coming out has a significant amount of work happening with all the other kind of associated works. So put together that you calculate the total amount of the cost of the battery, and then if you are coming out with a few number of batteries, it will be very expensive because you need to cover all these prices. Now, if you increase the number of batteries production and assume like the technology has came with replaced with another technology, then all your investment is at stake. The best example for battery design competition can be seen with Nokia. If we see Nokia, it ended up as a disaster because of two things. One, operating system. Nokia initially came out with their own operating system, and then Nokia then adopted with Windows. They adopted Windows operating system. But whereas the other companies, whichever were there, they adopted the Android and they came into the market, which indirectly was in 100% compatibility with Google. As a result, what happened? Today we don't see Nokia. At the same time, secondly, if we see Micromax that we used to have, India used to produce, that company couldn't sustain the competition from the Chinese or Korean and Japanese, South Korean and Japanese industries because of batteries. Long-lasting batteries. Even today, if we see sometimes in ads, we try to see Oppo long-lasting. They will say, I charge it for 2 minutes, it will last for a long time. So these technology, if now just assume you have manufactured a battery of that is suitable for Nokia, you have manufactured 10 million components, and altogether the next technology came and it took away the market. So all this investment is gone wrong. So you need to include all the possible parameters and put together all these parameters will become more than 100 or 120 parameters. And then you should give a weightage, which parameter is going to impact the final price heavily. And giving them weightages, you should now find out the best design possibility that will satisfy all these parameters. That's called design space exploration. And that's where, if you honestly say, many software engineers or CIE industry altogether is now inclined to. And that's where we also have a solution called HEATS, that is multi design optimization and design exploration softwares. So I'm just trying to share with you, like, this is the future where it belongs. I mean, future research belongs in this direction, wherein which you will try to consider all possible variables and then come out with the product. It's no more like parametric analysis. No more parametric analysis. Parametric analysis is now treated as outdated. We need to deep dive all the possibilities and ensure that the outcome that we have is the most suitable outcome for addressing the marketing challenges altogether. Now with this, now when I come to designing the batteries, along with the cost and all other manufacturing efforts, we do also have the other side, that is the chemistry. That means multiple cell chemistries, and then cell selection, which depends upon the uses, and thermal management. I'll be briefing more. I'll be discussing more on the thermal management down the line when I'm talking battery pack. So these four parameters: multiple cell chemistry, cell selection, sizing, and aging. If we see, these are concerned with a single battery itself. We need to address all this. And many times, I mean, I see in industries within India, we don't play around with multiple cell chemistries, but the rest of the three, like cell selection and its sizing and thermal management, is highly addressed within our indigenous market. I mean, multiple cell chemistries are addressed still at the university levels. Maybe if I'm correct, like IIT Kharagpur, I came across like they were into alkali kind of batteries, and there are a few other universities who are investing more into cell chemistry's point of view. But yeah, major industry focus will be on cell selection, sizing, and thermal management. So what are all engineering problems that we need to address is like we need to choose a cell chemistry, precise the battery pack, and then easily characterize the battery cell from experimental measurement, and then find out its suitability for thermal management, and then find out the electric drive line. I'll be briefing about electric drive line. Electric drive line means if I have a bunch of batteries in an automobile, how are they connected? It is going to give me effective outcome, voltage, right? What I am looking. So series and parallel, we all know. Can I collect all of them in parallel? Or if I connect all of them in parallel, I may get a good amount of voltage drop, maybe. Now, if I get that, am I going to utilize all the current in no time? Or if I try to connect them in a series, maybe it will be summing up, so I may get a better current densities. Now, if that is happening, then what am I going to utilize the same current densities till my vehicle last point? And above all, am I going to consume all the density, energy density that is available by the time I reach my destination? And if that is happening, then it's a disaster. We may, if that is not happening, then it may be a disaster. We may stop the vehicle on the road itself. Now, how to arrange this and how to connect this? This is going to play a very dominant role. So drive lines should be very important, and at the same time, aging. Now, when it comes to aging, I'll just try to give an overview from again our mobiles. If we carefully see our mobile, just assume you have a mobile phone. You are trying to charge it 100% every day. Believe me, your mobile phone will die by 2 or 2.5 years will be its life. But if you charge it till 90% and you don't charge it till it comes down to 20%, and if you try to repeat this, the life of the battery within the mobile phone will be doubled, almost 2 times. It's even proved now by R&Ds. I can share certain articles about this addressing these aspects. So this is called aging. Aging is always there. And second, self-discharging. If we carefully see batteries, they will discharge. You buy a battery, you just leave it like that for 1 year, and then you try to see the voltage drop. You will see definitely good amount of charge is already gone. This will happen because of the ionic movement within the batteries happening. So that kind of aging and self-discharge also need to be addressed. And battery management systems and control strategies should be there. Now, as I said, like series and parallel, you may arrange the batteries to get a particular efficiency. Now you found like thermal efficiency is there, but now the biggest unknown when it comes to battery pack, a pack of batteries, is which battery is going to discharge first. This is a very, very delicate issue. So you need to create a control system which will always cross check the voltage drop across all the batteries, and based on that it try to connect and disconnect the batteries with reduce the battery loads by connecting or disconnecting, or using the transistors, switch off, switch on. It should be operating in a way it should manage the overall battery energy at the same level. That means charging and discharging should happen more or less uniformly. This is what we try to refer it as BMS. And honestly, battery management systems is again a very big research area currently in industries. So if you say Tata Elxsi and Tesla and another companies which are leading, the biggest difference between them is BMS also plays a dominant role, which is one of the, that means battery and BMS is what the technology makes it different from each other. So BMS is also very, very critical subject. That means how are you going to maintain the uniformity while charging and discharging? Charging is fine, to some extent can be addressed, but discharging is on flight. That means when the vehicle is on road. So there one has to address, and that is going to play a dominant role. So these are all engineering problems that need to be addressed. So now I'll try to focus on certain solutions from Siemens, for whom we Prakrtiti Technics are partners. We do have digital solutions for these problems addressing. And at the same time, I will also let you know like what problems while using them I came across. And during this time, I feel the question and answer session is last, so that time we can discuss if you have any doubts about them. So now, when I try to utilize a digital solution, that is a modeling process for batteries, we need to address at different levels. First thing is microstructure electrochemistry. Now, what is microstructure level? I have an electrode, or say a layers have been kept on each other, but these layers need to be manufactured. So when you try to manufacture a particular layer of battery material, electrode material by doping certain ions, which is your patented ion technology, homogeneity is expected. But are you going to get the homogeneity right away? It is always verified by SEM technologies, SEM, and now maybe some advanced technologies. I personally have seen SEM being utilized for finding out the ionic distribution. So this SEM need to be verified and find out like whether lithium cobalt has been properly placed in collector and uniformly placed. It should not happen like it is totally kept at very high density at one place and another place it's not at all available. So the uniform distribution should be there. For that, absolutely the digital solutions are going to help. At the same time, experiments also are done in this area. Very large number of experiments are going on. And the second one is, okay, fine, at the electrode level, I have a chemistry ready. Now, can I develop a battery cell? Then in a spiral, or say like pouch battery. These are the two batteries. Well, what is the pouch battery? Pouch battery is what we see in our mobile phone, cut short. And then what is the spiral battery that we use in cameras or wall clock? It will be like that. I'm not saying it is exactly the same, but it will be looking like that. With different layers, the number of layers and density is different, but the output will be looking the similar. So the wall clock one is like cylinder battery, and the one you use in the mobile phone is like a pouch battery. Now with these batteries, once I create using the electrodes that I developed in the laboratory, if we try to create this kind of battery, is it going to sustain? The biggest question is the design is possible or not. For that, we have a dedicated software called battery design system, wherein which we try to create this geometry. We give all the inputs of electrolyte, this much of volume, and we say density, this much of volume. We keep all those inputs, and then what is the first thing that we are going to see is whether that is design practically possible or not. It may happen, we may calculate theoretically that I want to use an electrolyte of say certain ml. I have added them in a solid electrolyte. I have created doping, everything I have done. When I try to create a battery, my battery size may be increasing by 2 or 3 mm. Now, if we see from a single cell point of view, 2 to 3 mm increase in the battery size is honestly nothing. 2 to 3 mm, sometimes we may say it's a measuring error, right? In our engineering laboratories, we try to do some experiment, we say, okay, Baba, 2 to 3 mm is fine. But in Tesla car, if you see, there are more nearly 0.8 million, if I'm correct, 0.8 million cells appropriately connected. It may sound very surprising for me. Even I am very equally interested to find out. I know I haven't traveled yet, but if at all time permits, I would like to see a Tesla car. They said they will have a manufacturing plant in India. If at all that is there, I would like to see. I mean, these many cells they are trying to keep under the car on which we are going to sit and travel. Now just imagine 2 mm or 1 mm per one cell. What is the total volume increment? Into 1 million. 1 mm into 1 million. You can imagine the amount of increase in the volume space that is demanded by the car. At the same time, proportionally the weight of the electrode material. So we need to find out the optimum and the perfect design for the battery at the cell level. Now after having it at the cell level, we need to organize them. For example, I have a bunch of batteries. I'm organizing them like this pouch. If you see, the pouches are connected here in this experiment. We do have cylindrical cases similarly. And now when we have batteries together, what is the biggest challenge? The batteries while charging and discharging both the times, the natural state of the material is disturbed. So definitely there is a heat that is evolved. That means the ions get into momentum. Whenever there is a momentum of the ions, heat is generated. Now when we have the heat being generated, we need to take what will happen? There is a possibility of depletion of the material. That means the material may get spoiled. So in order to avoid the spoil of the material, we need to ensure that the battery material is maintained at the time of manufacturing, which is around ambient temperature or less than ambient temperature. And as I said earlier, I would like to remind it here. If at all battery management system, battery pack design, thermal efficiency design is done for say Pune, it should be re-verified for Mumbai. It should be re-verified for Hyderabad and Rajasthan separately. Otherwise, this system may fail altogether in addressing it. That much sensitive, because 2 to 3 degrees difference in the battery temperature can really harm the battery efficiency. So in order to maintain that, very highly sensitive thermal management system need to be developed. Fine. Now in the battery modeling process, this also includes. And what is the next level? I have developed a wonderful battery pack. Say this is the best battery pack with high thermal efficiency. You keep in Rajasthan, or you keep in Hyderabad, or you keep in Kanyakumari or in Kashmir. It is going to show you the best temperature, the same temperature, uniform temperature. Fantastic. Very good. Now can I keep it in my car? That's the biggest question again. If you can't keep it, then all R&D is waste of it. But if you have to keep it in car, what are other components? How are they going to behave? If I connect it to the powertrain, the transmitter, is the transmitter can be seated just above the batteries? If at all I try to keep take a battery layer and I keep my power transmitter above the battery, what will happen? it will happen, it will cut down the natural convection. Even the forced convection is hampered to a very good extent. As a result, my temperatures may increase. On the other side, if I try to keep a transmitter a bit away from this, then both of them need very good amount of volume. Can I provide this much of volume in automobile or say two-wheeler? I mean, two-wheeler, if you are trying to buy, it should not happen. The battery system itself is bigger than the passenger comfort, right? That is not designed. I mean, you are supposed to come out with a solution that is feasible from industry point of view. So there, you need to look into all the possible combinations of the vehicle system, powertrain system, and acoustic system, and HVAC system. All these system, windshield systems, and the radiation that is it is exposed to all those systems along with the cabin HVAC. You need to address the battery rearrangement. So this kind of system, if we try to take it at component level, it is going to consume a lifetime, honestly. How can we reduce the pricing involvement in all these things? Very easily by utilizing one-dimensional, most proven technology like AMISIM, wherein which you can try to use the system level generated models effectively. That means for a human, for a seat, say for a steering wheel, for a tire, lot of models are available because of experimentation till date. I mean, automotive technology is not started today. The invention of the steam engine is where first the engineering, I mean, we all have learned like steam engine itself, we started looking after the transportation, and down the line it floated to various levels. So from there, this much of experience and expertise when we have collected over the years, that all can be clubbed in various segments. And for each segment, if we try to develop a mathematical model that can accurately represent the particular component, using their combinations, we can have a very clear glance of what could be the possible outcomes. So this kind of analysis is called system design level analysis. And here is where we try to use AMISIM, a tool from Siemens that is going to help. That means Siemens, we try to provide end-to-end solutions like electrode, microstructure electrochemistry in Star CCM Plus, and then virtual design cells. We try to give it to battery design studios, and then from there we try to go for battery packs, and then we try to provide AMISIM. And what is the next step left? Definitely testing. Honestly, Tata Motors uses all of them. Tesla uses all of them. You name any company that is coming out with the competition in the EV, you will see Siemens solutions present there. That is from CAD till the vehicle production, including the digital twin that I am going to brief in few minutes. So with this, I will just like to give an overview of what is BDS, because I am trying to show you a product, because the product, along with the product, I would like to discuss about its possibilities, what can be addressed by the product, at the same time, what is happening in the real world that cannot be addressed. This way, I will try to show from industry point of view what are all things are possible. So virtual type of prototyping of when we try to do a cell, we can clearly define material property, chemistry selection, design exploration, aging, abuse modeling. Abuse means thermal abuse modeling, and system software co-simulations can be done, and these results can be exported to the next level thermal pack simulations. But what is the limitation of currently battery design studio is the leading software, but currently all other softwares also put together where they are struggling, other than lithium ion and their associated physics. That means fluorine residue extracts, cobalt extracts. If other than these things, the alkali part is not even addressed today in BDS. And alkali part is the leftover area from R&D point of view. It has been found from experiments that alkalis are highly corrosive. That is the reason why many countries are not interested. But when it comes to India, I strongly feel alkali should be the area where we have to focus. Because if we try to see from mineral point of view, we are blessed with lot of alkali metals. Honestly, that means to utilize the indigenous materials. Yes, I mean, that could be an area. So our software BDS can also be utilized to incorporate those inputs from laboratory and can be addressed. So from what we do in generally in any battery pack analysis at my places, we try to take the BDS and we try to design the battery here, and then we try to export it for thermal level analysis. Thermal level analysis is done in three-dimensional computational fluid dynamics software, star CCM plus, which can address fluid dynamics, multi-phase reacting flow, solid mechanics, rheology, so on and so forth in very detail. And as I was telling, like AMISIM is used as a one-dimensional tool where we try to use all of them and then we try to go for system level synthesis. Now, when it comes to the battery level, microstructure level, what are all the challenges is like a prediction of a spatial distribution of ions with potential within arbitrary multi-phase microstructure region. This is very important. If you see here, I hope you are able to see on the right side bottom, here you are trying to see star CCM simulation. This is computational CFD, computational fluid dynamics results. This is experimental result. Three-phase model. So we try to create electrodynamic potential models and then we try to see how these ionic movements are happening in clusters and how they are going to form a deposit and how effective the entire surface area of the battery is utilized. So this kind of binding work analysis, lithium battery concentration, how much is the total concentration we try to extract. And honestly, this is an R&D area. I mean, when I was speaking to Kamlesh, he was trying to tell me like R&D areas also you try to share. So I'm just sharing. Please don't take me other way around. I know there are many faculty members already here who are well versed with all these things. So don't take me other way around. I'm just trying to share what I know. You can correct me if I'm wrong. I'll be very happy to learn from you. Having said so, I will say battery concentration is going to play a dominant role, and very recent update is Tesla was initially it came with battery size, very less battery size with high energy density, and they launched a vehicle, and the Tesla EV vehicle is a revolution. I mean, it is a 2019 revolution vehicle, they say. That means across the world it is praised. But now what happened? They found like it is having highest thermal issues because of energy density. So in order to overcome that energy density thermal issues, they started increasing the size of the battery by retaining the electric electric density same. That means the lithium ion concentration is same. So by increasing volume, what happens? The density, the outcome, they are trying to retain the same by adding other materials that will help in thermal stability. So this cutting edge is the current area. Honestly, that is right now happening in the USA as well as in maybe in IITs also. Some of them would have already received the projects in that direction. So this is a challenge that is happening today. Excuse me, 1 second. Yeah, hi, I'm back. So yeah, maintaining the battery concentration and at the same time increasing the size they have found. But there is one more competition which is patented, so I just don't want to disclose their names, but I spoke to them. They were telling like retaining the battery density, energy density and increasing the size is actually going to cost Tesla more than what they thought. Rather, these people are telling like increasing battery size and increasing the electric density to a proportion can actually really help. So the competition is working in this direction. So two neck-on-neck competitions, they are coming with some technology, but both are in R&D. So that could be a potential R&D area. So what is the next area is developing equivalent circuit models. Now, how can you develop equivalent circuit model? If we see, we have duty cycles. We call duty cycle. That means I will charge to some voltage. I will allow discharge by of the battery. That means I received a battery of 5.5 volts. I will discharge it for particular time. Then we call it as, and we try to measure what is the drop in the overall charge. So this is called duty cycle. We see when we try to import, say from China or Europe or USA, I have a battery. How to develop a model for the battery? Then the procedure involved is I try to take the battery, we conduct a duty cycle search on that, and then we try to find out how the voltage drop is varying with the time. Similarly, how the current density is varying with the time, and then power density varying with the time, and then using them, we try to fit in the established mathematical models. Simple model is network model, set to resistance model. Maybe we all of us used in our undergrads. And now we come to the next level is the Delphi model, and then NTRG model and other models. So we try to create an equivalent circuit model by say curve fitting with, of course, a reasonable logical conclusions of the residence times. I mean the dissipating times with resistance and capacitance. So once we try to develop these equivalent circuits, using the equivalent circuits, we try to refit in the BDS and we try to see whether the entire battery is represented. That means battery representation in terms of physical is happening. Am I representing the battery along with the electrode is happening, and the thermal management is represented appropriately in terms of voltage and current varying with the time in terms of equivalent circuit, whether that is happening. So all these cross verifications we should do, and then what can we say is we have a battery and we have a model. Once you have that, believe me, you are the king of that particular subject. From there onwards, all the down the line R&Ds, I mean that one particular input will open door for 100 opportunities in terms of thermal management, like what you are seeing here. This is a project done in Netherlands by KU University student. I have this thesis with me. Who he was trying to develop a cooling jacket for this cylindrical batteries packs. You can see he placed a small unit. He calls this units. There will be 500 to 600 units in one single pack, and there will be 20-30 packs. So one single unit he has taken, and he was trying to develop a particular cooling systems for this. So he was trying to use CCM effectively for developing all this, and this is the outcome. The left side, what you are seeing is the outcome. If any one of you are interested, I'll share that thesis. It is a very great, very fantastic work. But of course, when it comes to thermal simulation, in his thesis, naturally he was doing this a long time. Now he would have become a very senior. But in those initial days, he was trying to take a uniform conductivity of this particular batteries. That means uniform conductivity means he said like in the lateral direction the heat conduction is very high, but in the longitudinal direction the resistance he gave very low, very high resistance. So he was forcing the heat to move. Whereas if we see the practically anisotropic conductivity is there for batteries. So from thermal management point of view, finding out this effective anisotropic conductivity of the battery is again a challenge. Again, one more R&D area. A lot of models are they are trying to come. So they say electrothermal simulation, and then some people will say 3D distribution and complex cooling system models are developed. But still, if at all any one of you are interested in this R&D, you can take it up as a challenge. Come out with your own isotropic or anisotropic models of conductivity within the batteries. That is again one more area, because using them only, all the softwares we can find out a very good feasible thermal solution. Now after this, we try to take it like this process, like BDS, we try to create a cell, then we build a simulation model, we try to mesh it, of course compute, and then we try to analyze it, and then we try to take it to the next level. As I said, it is about the AMISIM, and honestly AMISIM is the last stage currently where you will be trying to test. Industries, if you take any automotive major industry, they'll have this in number of licenses they'll have, because they have to test it before it goes to final outcome, means going for the production, pre-production test phase. So that time they will try to find out the system level solutions, and wherein which we try to find out various mathematical models that you have developed at battery level, battery pack level, as well as the integration of the battery pack level, and as well as if you are developing your own indigenous vehicle altogether. Like as I said, like the IT students are coming out with their own vehicle, self-balance, auto-balance vehicle. It's a very good vehicle. I mean, they don't need a stand. The vehicle stands still without using actual stand on the ABS system, using an effective ABS system. So such a thing, if you are coming out, then you need to develop mathematical model for all that, and then that need to be validated and then incorporated in a software like AMISIM, or if you have MATLAB, then yes, of course, MATLAB you can develop it effectively. So that is again a pending area where dynamic model and static model, aging models like this, so on and so forth, model developments are happening at rapidly across the globe, and the door is very widely open. It's a ocean, honestly. So when we try to use these two effectively, we can find out with a very good analysis and full XEV, we say. That means simulation wise electric vehicle driveline, entire thing has been found with coupling both these things. And sometimes we also try to use star CCM plus, that means component level integrated with the system level, and then we ask for the optimization. Means we try to as I was referring in the heats multi-design optimization, we try to give a task wherein which we try to find out the most suitable component configuration that can really fit at the system level also. That means we try to create all these as a design variables and then try to incorporate it. That way, this effective combination is going to help much more in saving by all means. So like this, we try to do, as I was telling, like heats MDO, we try to give, and then we try to do designs. And you can see like now we have a challenge here to reduce the size and increase the thermal capabilities. You can see the temperatures at different sizing combinations. We are trying to vary the sizing combinations. And then we wanted to reduce the weight also. So we have found various designs and combinations using digital, and then we found the optimum design, which is I guess this is okay. So the reduction in the weight was found to be 35% and 30% improvement in uniformity in the temperature. So this was achieved easily using the multi-design optimization approaches. So that includes Siemens comes with a Sherpa algorithm, which is a patented algorithm. So we try to utilize these patented algorithms for getting this achieving these tasks. And this is again from the same guy. I mean now okay, he's Dr. Suman Basu. His thesis, he has seen like the cooling. He has developed also serious connection, and he tried to find out the trade-off. And the left side, what you are seeing is a Tesla vehicle. Yeah, in Tesla vehicle, you can see the powertrain is here. The dense battery packs are here. Here, exactly here, where in which you have a lot of batteries on the downside. And the charging is simply connected from here, and the powertrain motor is kept here, and it will be driving the vehicle. It will be pulling the vehicle this direction. In the driving direction, and the vehicle will be taking the movement. Of course, aerodynamics and other things are already very good for optimized for Tesla vehicle. So they have tried to come out with this. There was another vehicle manufacturer, if I'm correct, Hyundai. They tried to come out with a car where instead of these batteries, I mean like this packs, they try to fit a big pouch cell battery that can take care, I mean, continuous supply of electricity for say 480 kilometers. That was 500 kilometers. That was their stake. But what happened? Both this as well as there with the big pouch battery, the biggest challenge was structural stability, which I haven't briefed here. Now, what is structural stability? Car is not supposed to. We don't expect a car to simply flow very straight, very smooth without any resistance. We all know from our childhood, even today, we know our roads pretty well, how many bumps we'll have. So the battery pack itself, if it start oscillating, it will have structural instability issues. Now structural when coupled with thermal, it is exponentially it will become exponentially challenging. So that also need to be analyzed. Now what is the advantage that Tesla enjoyed over the Hyundai is, the Hyundai, the single pouch battery, if it undergoes structural instability and maybe achieving the natural resonance, if it undergoes breakage, that is gone. I mean, the Tesla is gone altogether. The Hyundai is gone altogether because of using pouch. But if we see the Tesla, because small number of batteries may get damaged, they are still at the safe. That means car undergoes a sudden break or it hits a bumper or something goes wrong, the damage is very minimal. still it can be driven to some point where the repair can be achieved. So that advantage they had. And what you are seeing on the right side is about the cooling system. You can see the parallel cooling jackets. These are the jackets developed wherein which the coolant flows from bottom. It will go through these small thin plates and then it will try to cool down the system and maintain. So this is thermal management. So battery pack cooling, absolutely it's a very big R&D area. So when I try to see digital twin production, it is about more about collaborating manufacturing, high fidelity multi-physics and design exploration. So yeah, now I'll try to move on to the next one, wherein which we will try to discuss challenges like this. That means electrolyte I want to fill. Can I effectively fill electrolyte very fast with a design that is suitable for filling it very fast? I mean, it may have uniform. If you keep a cylinder, it may occupy all this volume. Instead of all the volume, I want to use a volume that will carry optimum space. So such a component manufacturing decisions need to be taken. So CFD analysis can help you in design optimization. But at the same time, whether manufacturing feasibility should be there or not, we will try to see in the next slide. So meanwhile, like any one of you have any doubts till now? Would you like to ask, or shall I proceed with the battery manufacturing challenges for a few more minutes?
Okay. You can continue. I'll just see if anybody has put a message. No, there is no message. We'll take the questions at the end.
Okay, sir. Okay. Yeah. Now, when it comes to manufacturing of EV vehicles, the challenges are. Yeah, the challenge is not just for the battery availability or its size. It's more about the amount of number of batteries that we can produce and fit in the automotive vehicle, and more how fast we can develop the pack and deliver. Say Tata Motors want 1,000 packs and another company want 100 packs. These are called contract manufacturers. Like Amber Enterprises in India is a contract manufacturer for all kind of air conditionings. You take Samsung air conditioner, or you say Blue Star, or you say not Voltas, but yeah, Blue Star or Samsung or LG. You buy any air conditioner. Technology will be small different, but the contract manufacturer remains same. That is Amber Enterprises. That's why I guess they are getting popularity nowadays. So similarly, the contract manufacturers who are under high stress, so they need to understand how to address these challenges. So if you can address the challenges upfront, you can do much better. So if we see, like, of course, these are the important things. I will try to now I will also try to show, like in Asia, what companies are there, vehicle startups. These are the major startups, I should say. Like in Asia, Wellmister, Neo and Byton. I mean, these are Chinese companies. Wellmister is a French collaborated company. Others are Chinese purely. And in America, of course, Faraday Future and Rivian and Lucid. Lucid is getting very high attention nowadays because of their success. And Socon SF Motors is again, SF Motors is a collaborative company. Whereas in Europe, Rimac and Electra and Unity, these are all industries which are getting into vehicle startups. And as I said, Tesla, I mean, this, when the slide was prepared, it was in last year when we tried to prepare about the marketing solution. And Tesla that time was starting in China. But because of the corona and post-corona sequences, Tesla shut down their biggest plant in Shanghai in China, and they are trying to shift this. I mean, government of India is dealing with them to bring and establish this one into India. We don't know, but I guess if at all that is happening, it's going to produce nearly 5 lakh electric vehicles a day, or sorry, a year. And those, that is the level at which Tesla is trying to come out. And Fiat Chrysler is also trying to invest in a Jeep SUV models. So this is the volume at which it is happening. And of course, from India, I don't have, I just saw the recent results proposed by Tata Motor, but the data is not fully given. How much of the auto component, that EV component was there? That was not disclosed in their auditing report. If at all I come across those auditing reports, I will definitely share with all of you. So yeah, but General Motors are now trying to close some patents and try to launch. And if I'm correct, like Vaptech, if you see, Vaptech is trying to come out with the electric vehicle itself, battery-based electrical vehicle. That means locomotive we call, no, engine, electric train engine, locomotive based on the battery. They are trying to come out. That is an associate of GM previously. Now it is a fully established industry called Vaptech. Entire electric vehicle locomotive is going to be run on battery, and that they are trying to manufacture for those countries wherein which it is supposed to run at -20 to -40 temperatures. It is frequently exposed to these temperatures, and those countries, that is the Russia countries in Russia, as well as those countries Latvia and other those countries which are exposed to these temperatures all the time. There it found like environment is very precious because of cold temperatures. The emissions using any other kind of thermal power or all these emissions, because of cold temperature, these emissions are retained there. They are not going away. For example, in India, what happens? We have an emission. Because of the hot temperature, the density becomes lighter, and there is a migration, there is a flow of happening. So the carry forward of the pollution is taking place. As a result, the distribution is happening. In these cold countries, that is not happening. So as a result, for them it is becoming a very top one priority. So EU majorly is investing in these ventures. Even Russia is investing in ventures. And Vaptech is one of the company I came across who are trying to come out with a locomotive that can address this issue. And in India, like Electra is a company, very good bus manufacturing company. So yeah, so manufacturing solutions, we need to address how entire process is manufactured. So lightweighting, if at all new materials are there, how fast we can do, and the battery production, and then EV platforms and supplier evolution, we need to include all of them. So if we try to see what is the electric vehicle, what is the cost, which is the cost effective parameter in battery electric vehicles, 50% is the powertrain cost. Powertrain means the battery as well as that motor put together is, we call it as a powertrain. And with that, if you try to separate the component, then battery pack is going to effectively 35%, and then electric motors and rest of electronics are 15%. But if we see recently, this picture is now getting changed. Batteries are filling this space of 50%, and powertrain cost is getting down day by day, because IC engine powertrain technology, whatever we have, the power transmission technologies we have, they are rapidly trying to incorporate. Honestly, if you see the Tata Nexon vehicle that is released, you don't see a very significant design differences in terms of powertrain. But if you see from the fuel supply, the energy supply point of it is entirely different. So they are trying to use this, whatever is the experience is there here. So, but yeah, overall cost lies between with these two. You can clearly see 35% plus 50, almost 85% of the cost goes with battery pack and powertrain. All rest is put together to 15%. So any enhancement in this area is going to save a lot. So battery pack cost, if we try to see, manufacturing costs are coming down because the market is increasing. But at the same time, this is going to come down to some extent only. There may be a goal like 2030, we try to bring down like that. Statisticians, they try to show this one, but they are not considering the other part, that is the scarcity of the raw material. So that if we try to incorporate, this curve is going to stop somewhere and get saturated. So unless new technologies are added, this is going to play a very crucial role as far as the EV roadmap that the entire globe is working on seriously. So yeah, the 20 plus gigafactories in construction are constructed by Tesla. So I can share this information with you. Electrive, there is a magazine wherein which you will find all these things. So you can see Tesla is the aggressive player as far as EV is concerned. So in order to balance the economies that are involved in all this battery pack manufacturing, automation and optimization at all stages is designed. So product design, we have mixing, dispersion, coating, drying, calendaring, drying. All these are very, very important, and coming out with packaging assembly. So if we try to design the digital world, so we can at the battery pack level, we can use that battery manufacturing, we can use battery design studio for creating the battery. Now with that integration to the next level of planning of the production, we can create this as an input to the production world, and then production engineering, digital equipments we can see, and then integrated plant, and then service. Now where does the solution actually, Siemens manufacturing solution, play a dominant role is, if you see from manufacturing point of view here, where the human is going to play a dominant role. I mean human intervention, from other than you should say like software intervention or at the lab intervention. So when we try to see the at a very high scale of battery manufacturing, mixing and dispersion, that means achieving the homogeneity in the materials, and coating of those materials and drying, and then punching, and then assembling them, or if electrolyte filling should be there, and formation and grading, and then of course the battery manufacturer should pack them appropriately. He may create a battery pack, but the pack itself need to be packed in hundreds of numbers, and that should be transported, and make sure the transportation is not hindering or affecting the whatever we have transferred. So that, and module assemblies, and packing assemblies, maintaining. So all these becomes the enterprise challenges. They are not more laboratory challenges. Laboratory challenges are more or less like addressed here in the first step, product designing. From second onwards till the fifth one, all other challenges will come into existence. So these are all again opening a new door of equipment. Unless we digitalize them and we try to visualize them before getting into the plant, original plant, we are going to be hindered. So here I'll try to show like a new few of the challenges instead of going in further details, keeping the timelines in view. I'll try to give you a glimpse of happening. You can see like challenges is in new critical components in vehicle powertrains, a new volume production speed. You can see how a battery pack is. Right side is what is a battery pack here. If you open that, they try to use, of course, a lot of robotics. So robotics are used, but yeah, this is how the battery pack look like, and you can see how dense the pack is. And human intervention is very much reduced, because if we try to increase the human intervention, error prone is increasing, and the speed can be hampered. That's what many big automotive companies feel so. It may be true to some extent, but it is always disputed, of course. So now how can we redesign and manufacture the process? Our automation can be done digitally, so that we can involve the robotics and save the space of manufacturing. That means I want to come out and manufacture the battery pack, but I don't have acres and acres of land for getting this done. Like USA, every plant will have a lot of area to be done, but we know like India, SEZ and all those things have its own limitations. So if at all you want to come out of those things, optimum utilization of the space should take place. For that, digitalization can really help in terms of establishing the robotics. And you can see at the CAD level we try to do. Now if we try to see the manufacturing of the battery, it's now more like we try to develop in lab, and then we simply go and give the draft copies to industries. It's nowadays 3D printing has replaced a lot of these companies' raw material processing. So we try to come out with CAD, and we try to integrate with CAM, and then we try to give what should be the outcome, and it is done like this. Very clearly you will come out with a manufacturing process. And here when we try to create using a 3D printing, you can see we can also see like the height of the human beings involved, and we can see whether it is going to hamper the process or not. I mean, if at all the movement of this battery pack by automatic robot, it should not happen. The robot is going to hit the human being. So the digitalization can help us in really visualizing the manufacturing plant itself. That way the layout, overall the architectural layout can be optimized. And now you can see how the PLM, which is based on CAD, can be used. You can see the previous picture we had robotics, and here you can clearly see how a robotics can be visualized prior to its utilization. That means this the robo on the left side, it is trying to take out the pack and it is replacing. It should not go and hit the right one. So this timing can also be modeled. So this is called a digitalization of the plant, or we say digital twins are produced like this. So once we have, then we go for the tooling or shop floor. Okay, I'll try to show the shop floor. You can have a glance of shop floor. This is one of the best visualizations. You can see how digitalization can help people in the office. This is administration office. You can see the vehicles taking away. So you can see how the place they are placed here very clearly. So anode punching, cathode punching, and then electrolyte filling divisions, staking divisions. You can clearly see very detailed the seating arrangements and various arrangements also can be visualized very priorly. So this kind of digitalizations are nowadays produced and very much preferred before we start any plant, because this will help in avoiding miscommunication among the various divisions and delay in the communication between the divisions, delay in transportation, as well as utilize the area very effectively. So these kind of developments are now happening for manufacturing point of view. So once we try to develop all these aspects like identifying the issues in advance, production issues in advance, cost issues in advance, and transportation issues in advance, and so on and so forth, we can really come out with the low cost batteries manufactured in billions. That's how we can achieve this task. So with this, I'd like to now open myself for a question and answer. So I hope I have shared whatever observations I had, Aqleem. So you can guide me.
Sure. In chat box, 2 questions are there, but I'll request participants. I'm just opening up everybody. Take care that one at a time you all just unmute yourself and ask the question. Raise your hand. I mean, press the raise hand button and then I'll unmute you all. So I'm unmuting participant number F16. You can ask the question.
Yeah, hi, a small request. Just tell your name. Please tell me your name. And
I am Venkatesh. In hybrid car, they are using nickel metal hydride, Toyota Prius. Why not they are going for lithium ion battery? Nickel Prius is most popular in US. Millions of cars are there.
Yeah.
I want to know why they are using nickel metal hydride batteries.
As I said, sir, it is the availability of the material. Honestly, till now, whatever I have seen, through my reading, what I understood is their economy itself is based on they plan according to the available resources. They don't go with the technology. Even it gives lesser density, still it is, they say it is okay because nickel is available indigenous. Okay. There can be other advantages. I mean, if I say lithium gives a better power density, maybe there can be some additions to nickel, cobalt, and other combinations. That particular combination may give another density. But what I say from my perspective is, it is the availability. As I said, like lithium resources and natural resources are heavily with China right now. It is a proven fact. USA doesn't have so much of lithium, so they may have the access to nickel more. So they are maybe preferring that. I hope that is the only possibility I see, because otherwise the technology point of view they are competitive.
Okay, sir. Lithium ion is more expensive.
For us, that's what. For us, not for Chinese itself. I mean Tesla. That's why they want to open. Yeah. Tesla is now opened a plant in Shanghai just to take advantage of the same. If COVID-19 was not happening, believe me, by now Tesla biggest manufacturing plant will be from China only, because they wanted to take that advantage.
Okay, thank you, sir.
Thank you, sir.
Participant number F060, I have allowed you to unmute.
Hello.
Myself Rushali. I'm a research scholar and I'm working on battery management system.
Okay.
Sir, I would like to ask that I have actually developed an electrical equivalent model in MATLAB. So I was able to match the characteristics which are provided, like battery voltage, charging voltage, and current. And I was able to get the graphs. Now, if I have to practically implement it, how will I be able to do it? Because that was my question.
Okay. In that case, I will just give you an overview, but I will be happy if you can write me. I can help you more. So when we try to have the equivalent circuit model, wherein which you have voltage and this responses readily, we try to utilize that as an input in electrodynamic potential equation. Okay, in a transient simulation in the thermal management systems. That means in thermal analysis, you create a 3D model. There you try to use this as an input, so that when you start the transient simulation by varying the voltage and current, so based on your model, it will understand how much is the voltage. I mean, if you have distributed model, I don't know what you developed, but if I guess it is distributed model. You said you fitted the curves. So if you have that distributed model, it will be the distribution of the voltage across the battery, and the circuit can be formed. So naturally, proportionally, the temperature distribution can be formed. Okay. So that will be the next step.
Okay. And one more, sir, that you had told about PDS. So that does it take into account those anti-balancing cells?
Yes, it will take. Yes, it will allow you to incorporate. That means in BDS, if you want to use for this particular application, what we will do is we will give input parameters. It's a very good thing that you have found already these parameters. So we try to give those parameters into the NTGT or other models, whatever model you have developed for equivalent circuit. And geometry we try to create in BDS, and the combination we will export to star CCM plus, which will readily interpret and also allows you to create a serial as well as a parallel packs. That way it will be very, very useful now. And you can carry on with thermal analysis. So you are from IIT?
No, I am from Sardar Patel Institute of Technology. SP.
Okay, why? SP. Okay, yeah, I mean, I hope all the participants have my email ID, Mr. Aqleem.
No, email ID I have not shared with them. If you allow, I'll share with them.
Yeah, I mean, you can share with them. It's okay. Email ID, but not mobile, of course.
Sure, yes.
So, yeah, Miss Vaishali, you can write me. I'll be sharing other R&D details with you. Okay.
Okay. Thank
you. Next we can discuss in more detail.
Yes. Thank you. I'll mail you.
Yeah, thank you. Next
there is one question in the chat box. What is the significance of SOC and SOH and how it is calculated for battery?
SOC is nothing but a state of charge. That means I haven't come across SOH. Honestly, I can get back to you on that. But SOC is a term that I use frequently. It is state of charge. So when you are discharging actually, or charging or discharging, both the ways, you will try to see at a constant particular amount of current, how much time it can give output. That means if I'm expecting a particular current density of 9 amps or a particular power density in watts per meter square, like that. So in that case, how much time sustainably it can give me, that we try to find out using SOC. So we say half cycle it can give or full cycle it can give, like that. So that's where it plays an important role. Because no battery, even though we try to buy a battery in our homes, we can see like to some extent it works pretty well, and then suddenly it drops. So we try to find out where it will drop. Means after so much time it may drop, or at what condition it will drop. So that we can say like this battery can be utilized with means significantly till this time. For example, I'll make it simple by giving example. If we say like a Tata Nexon car, they recently said it can be used till 480 kilometers. So the SOC at the time of manufacturing should be a minimum 10% margin. That means actually it may be for 550 kilometers, but they say it is around 480 kilometers. And then they guide us to use it less than 10% more, lesser. So that's where we try to use. That is one application. Another is, of course, developing these thermal models. We try to couple this voltage with the current density with the SOC, and then we, based on the SOC conditions, we try to say current density. Then the current density will give us the joule heating, and from where we use the thermal analysis. So both the ways, yeah, this parameter plays a very good role. As far as SOH is concerned, I haven't came across, but I can get back to you on that. I hope I answered your query.
Okay, one of the participants, SR Somanshu, he has asked why we are not looking for flow battery technology for electric vehicle. Is there any reason or just trending lack?
That's a very good question. Actually, there are many questions unanswered in our country, and it is one of those questions. I should be honest with you. Yes, because see, why don't we do, I mean, why Sundar Pichai is CEO of Google in USA? Why not in India? That's never answered. Maybe we don't encourage our own people. I know even today we don't buy Ampere two-wheeler. We try to buy BMW two-wheeler. If the BMW launches a two-wheeler saying electric vehicle, we are ready to pay 8 lakhs, 9 lakhs. But at the same time, Ampere vehicle is available in 2 lakhs also, we don't pay. It's not like we don't have talent or resources. At least now we don't have that problem. And now technically I would like to add one more point. As I said, like a reserve point of view, if you see, we have to be honestly, we should agree like lithium is reserves are very high in China, and nickel, as other attendee was asking, nickel reserves and cobalt reserves are with America, and of course America has all kinds of resources because they loot Africa and other countries. They have different approach for taking away raw materials, but the biggest challenge with India is in terms of raw material. Like we don't have access to raw material. I would like to share one example that I came across. Copper ore is found in India, but we extract the ore, we supply to China, they prepare copper, they extract copper out of it and they sell back to India. We are ready to buy it reasonable price. We don't take it directly because what is the problem? Ore extraction, that is mining license, is obtained easily, but licensing a new steel plant from Green Revolution people till the government, I mean from bottom to top, we have big problems. I don't want to comment. I don't feel this is the right dais to comment on the policy makers. But yeah, that is the problem.
Okay. Any other questions from the participant side? Nobody has raised hand and no message in the chat. So I'll take it that at present nobody would be asking further question. Any question is there? Dr. Phanindra, I'll give your email to them. So I hope that will be okay for you.
Yeah, fine, sir. No issues. Yeah, they can contact me.
So
I get okay. Why don't you keep a test? Like, how many of they are listening? Just ask them to raise the hand. Let us see whether listening or sleeping. Am I boring?
That's one of the thing in online sessions that we are facing since March.
Absolutely.
Yes,
I mean,
correct. As requested by our guest speaker, I would request all the attendees to raise your hand. If you are in on desktop or laptop, it is immediately next to the chat box icon at the top. And if you are in mobile, you just click on the three dots that is available next to the mic, and you will find raise hand option. So yes, request everybody to raise hand. Yes.
Oh
Now
wow,
you can see.
that's a good number. Thank you very much. I thought I'm boring and people would have left.
Oh,
Actually,
no, how can you bore? It's such a nice speaker. How can you bore people?
No, sometimes it happens because
And
they
the
might have uttered.
knowledge that you are sharing, nobody would afford to miss it.
Because I remember one time there was an example there. I'll just tell this is on a lighter movement to relieve all of you. There was a singer. He was singing a song. Then people clapped for him. Then they said once more. This fellow sang again. They said once more. It went on for 20 times. Then finally he stopped and he asked, "Why are you making me once more?" Then one of the audience said, "We thought you will correct yourself, but it is not happening." So I don't want to fall in such a trap. So I would like to have a genuine feedback from you. Please let me know where I have to improve.
Yes. I'll just see if one chat has come. Yeah, email ID. One person has requested. Sir, what is the email ID? I'll put on the WhatsApp group. All the participants, I'll put on the WhatsApp group email ID.
Yes, you can write me. All of you. I'll be very happy. I guess some of you are my LinkedIn friends also. I mean, and some of you know me, and so just feel free to contact me. Whatever I can, I'll be happy, and I'll be very happy receiving questions always technically, because that's where I can learn myself. Honestly, there is a lot to be learned. So definitely we'll be in touch, and together we can have more better learning. So please write to me, no issues at all.
Okay. So anyway, we come to the end of this session. Formally, I would. It is an honor for me to propose this vote of thanks, Dr. Phanindra. It was really very good that you graced the occasion by your presence and shared your knowledge, your deep knowledge. And we and every participant over here would agree that we gained a lot from whatever you shared. Yes, definitely there are lots of things that you would intend to share. So in future, if something is there, we would definitely again request you, and we are expecting that again you will come like this and take lectures and keep sharing your knowledge. So thank you very much.
Thank you, Aqleem, and thank you, Ilaj, and other friends for inviting me to this great occasion. It is my privilege to share. I hope I was sharing from industry point of view, but not theory. I hope it's not boring for you from
Actually, that is what we were expecting, or people have attended for that only. We want industry perspective, more of it.
Yeah, so we keep coming across various challenges. We also know when we try to communicate with the original manufacturers, there are a lot of limitations. And as rightly one of our attendees have asked why we are not having indigenous solution. I mean, that is something that should be churning in all our hearts. We should address it. And another participant also rightly pointed out there is America is inclined for nickel, and someone else, China is inclined for lithium, and even though there is a cost and all these parameters. Now we have both of them. What about India? We have blessed with alkali earth metals and other precious resources. So we should also think in a term like, can we come out of these areas? And there are many other areas like related to electrochemicals, like bioelectrochemical systems. That itself is a very good topic. So please take this up. You are all into academics, so whatever research you do will be reflecting in engineers. And honestly, if any of your students, I know you all know the market, but just a gentle reminder, if any one of your students say that there are no opportunity, auto slowdown and all that, please don't believe that. It's a fake news. Actually, industry needs it. Tata Motors, if you see the yesterday results, they booked the profit. So it is fantastic. And there are more opportunities coming in this sector. It is a very, very big domain, you might have seen. But what is expected by industry is a ready inclination. So please work in that aspect. And all your dignitaries, faculty members in your research, please include the students as much as possible and come out with innovative solutions, and definitely we all are going to have a great day. And thank you very much for listening me for all this time. Thank you.
One small thing on WhatsApp, I just received a message. Okay, sir, really the session was informative. A very typical question: are you going to send the material of the session, like your PPT in the form of PDF?
That is having lot of information that can't be disclosed. Okay. I'll see whatever I can share will be shared. If you send me material. I would like
to inform the participants that this session is live on YouTube. So anytime you can visit the YouTube channel, which is shared on the group, and you can view it anytime, whatever content he has shared.
Yes, that way is okay. Yeah, but I can't share the original content because it has a certain information that I cannot be. Correct. Okay, I'm sorry, but you can write me an email. I will be happy sharing whatever is possible for me.
Okay, no problem.
That is possible.
Yeah. Okay. Once again, thank you very much. And if you permit, I will end this session then.
Yeah, fantastic, sir. Thank you very much, sir. Have a great day. Have a great day, all of you. Bye, sir.
Bye. All the participants, the feedback form is shared on WhatsApp group. Just fill the feedback form.